Hi, I'd like to show you how this program works. Here's a program written in Kotlin, which is a language that runs in the Java environment, and it uses processing. You can learn about processing from processing.org. Let me run it from here. The application that comes up, the desktop application that comes up, comes from processing. Here it is. It shows you a bar graph that corresponds to 2 octaves of a minor pentatonic scale. And it sorts it a little bit each time. And you can control the speed of it with the mouse position. And it's done. And then it does another one. I'll slow this one down so you can really hear it. If you kind of scan it from left to right while you listen to the notes, you can hear that the pitch corresponds to the height of the bar. Okay, let's see how this works. While it's running, let me jump over to Sonic Pi. And you can see that Sonic Pi is playing the notes that are coming in from the Kotlin program. Okay, let's push stop here. And we'll come over here and we'll quit this program. On the Sonic Pi side, we're using this sync function to receive messages from the Kotlin program that arrive via Open Sound Control. Something I'm just learning about, but you can read all about that protocol, and there seem to be client and server libraries for lots of different languages. So how does this work? When a message comes in, it pulls out the first number, which is the tempo. So it uses with beats per minute on the first number that's passed to it. And this is what's coming in here. So here's the tempo, and then these are the notes to play at that tempo. And then it uses play pattern to play the notes. So the Sonic Pi part is really simple. I'll quickly take you through the Kotlin code. This is more about Sonic Pi than it is about processing, so I'm going to not give a lot of detail about that, but this is, if you're familiar with Java, this code is not too different from Java. It's maybe more like Scala. So what do we have in here? Some configuration constants. Here's a little comment. It visualizes, and with the help of Sonic Pi, musically plays a representation of sorting a sequence of shuffled notes using a bubble sort. And here's the 2 octaves of notes. And these are the dimensions of the window. Processing programs usually have a setup function and a draw function, and the setup function runs once, and this is just doing some setup stuff. And in draw, this is where the action happens. So we look to see if it's time to do something, and if it's not, we don't do anything, we just return. And we set the frame rate, and we set up quadrant 1, and this is just because the origin by default is at the top left, and Y increases going down, and so this just adjusts for that. And we set the background color, and then we call bubble pass, which will take one pass through a bubble sort, and if the sort is complete, then we shuffle again for the next time. Otherwise, we draw the notes. And then we calculate the beats per minute based on where the mouse is on the x-axis. And here's the interesting part for Sonic Pi. We send an open sound control message, which we're calling play, and then we're giving it the data, which is the beats per minute and then the notes. What is Sonic Pi, you ask? Let's go to see where that's defined. That gets created here when the object is instantiated via this OSC port out. And what's that, you might ask? Well, let's go see. That comes from a library that we're using. Okay, I think that's it for this. See you next time.